Hello, welcome to section 3.4, atomic number and atomic mass. The atomic number is specific for each element. It's the same for all the atoms of an element. It's equal to the number of protons in an atom. So usually you'll see this number above the symbol. And in the periodic table, this is your atomic number. So if you know the atomic number, you also know what? The number of protons that it has. So the atomic number is equal to the number of protons. If the atomic number of hydrogen is 1, then every hydrogen atom has 1 proton. If the atomic number of carbon is 6, every carbon atom has 6 protons. Copper, atomic number is 29, so every copper atom has 29 protons. The number of protons for an atom does not change. If it changes, it's no longer that atom. So every atom of lithium has 3 protons. Every atom of carbon has 6. Protons don't change, okay, unless they're radioactive, and we're not going to talk about that right now. Atoms are neutral. If for a neutral atom, that means that the net charge is 0. In order to have a net charge of 0, you have to have an equal number of pluses and minuses, okay? So that means that the number of protons, which are positively charged, is equal to the number of electrons, which are negatively charged. So the atomic number for aluminum is 13. So that tells us it has 13 protons and 13 electrons. So the overall charge of an aluminum atom of an element is 0 because you have 13 pluses and 13 minuses, okay? So we can use this chart here and see what we can tell about these elements. So what you need to do is you need to look at your periodic table and see what is the atomic number of each of these, okay? And then what does that mean for protons and electrons? So pause it. Look at your periodic table and fill in this chart. Okay, so notice that these numbers are the same going across because we know that if the atomic number is 7, that means it has 7 protons, 7 electrons. The atomic number for zinc is 30, sulfur is 16, so we also know number of protons and electrons of that element. The mass number, okay, is different from the atomic number. The mass number represents the number of particles in the nucleus. It's equal to the number of protons plus the number of neutrons, because remember, that's where we get most of the mass of this atom. It's always a whole number. It does not appear in the periodic tables that I had earlier, but some periodic tables will have it below the symbol. So they'll have the number, the atomic number above the symbol for the element, and the mass number below that. So you have everything right there together. All right, so for hydrogen, you have an atomic number of 1. The mass number is 1. That tells you from the atomic number you have 1 proton, 1 electron, and how many neutrons? Well, if the mass is equal to protons plus neutrons, and mass is 1, to get this number, the number of neutrons, you'd say 1 minus 1 gives you 0. So it doesn't even have any neutrons. Let's look at chlorine. Chlorine atomic number is 17. Its mass is 37. Okay, so how many neutrons does it have? 37 minus 17 equals 20. Gold atomic number 79, has a mass of 197. The protons is 79, so the mass minus the protons, 79, equals 118 neutrons. See how that works? So the number of protons equals the atomic number. The number of protons plus neutrons is the mass number. So if you rearrange that to find the number of neutrons, it's the mass number minus the atomic number. For your learning check, an atom of lead has a mass number of 207. How many protons, how many neutrons, and how many electrons? But the first thing you're going to have to do is what? Find out what the atomic number is. And the atomic number, I believe, is 82, if I can write it with this thing. So how would you find the number of protons? Right, the number of protons is going to be the atomic number. How many neutrons is it going to have? How are you going to find that? You're going to have to say what? 207 minus 82. And then the electrons are going to be what? The same as the protons, if it's going to be neutral, so that will be 82. And so 207 minus 82, 125 neutrons. So lead, whose atomic number is 82, has 82 protons, 82 electrons, and 125, which is the mass minus the number of neutrons. So that's the end of section 3.4. We're moving along really quickly. If you need to go back and review any of this, you need to do that, or you can let me know and I will work some problems for you online.